We're going to continue our study with specific formulas related to trig functions. Last time we talked about the sum and difference formulas for sine, cosine, and tangent. Today we're going to be talking about the double and half angle formulas. So first let's just write down what these double angle formulas are, and then we'll get to the half angle formulas. So double angle formulas, as the name suggests, we're really just working with angles that are doubled. Instead of a sum of angles or a difference of angles, we're doubling an angle. So sine of 2u, so u being the angle that's being doubled, is equal to 2 times sine of u cosine of u. Now if you really think about this, the double angle formula is really just derived from the sum angle formula, and think of it as sine of u plus u, right? That's two of them. So sine of u plus u would be sine of u cosine of u plus sine of u cosine of u, which is just two of them, so you have 2 times sine of u cosine of u. So just in case you wanted to relate that back to what we did last time. Okay, cosine of 2 times u is equal to cosine squared u minus sine squared u. Now, this one does have multiple forms because as you can see there's a sine squared, there's a cosine squared. You could replace with the Pythagorean identity to get other forms. So another form would be 2 cosine squared of u minus 1. Another one would be 1 minus 2 sine squared of u. Next we have tangent, so tangent of 2 times u is equal to 2 times tangent of u all over 1 minus tangent squared of u. So those are the double angle formulas for sine, cosine, and tangent. Next we have the half angle formulas. Again, we'll have one for each. So sine of u over 2 is equal to plus or minus the square root of 1 minus cosine of u all over 2. Cosine of u over 2 is equal to plus or minus the square root of 1 plus cosine of u all over 2. And then tangent of u over 2 is equal to 1 minus cosine of u over sine of u. There's also an alternate form, which is sine of u over 1 plus cosine of u. Now, we'll talk about this a little bit again later, but just note that this plus or minus square root is not saying that there are two possibilities for, say, sine of u over 2. It really depends on where u over 2 is in which quadrant, right? So if u over 2, whatever that value is in quadrant 1 or quadrant 2, then you know sine is positive. So it would be positive square root of 1 minus cosine of u over 2. If u over 2 is in quadrant 3 or quadrant 4, then you know that sine is negative. So the answer would be negative square root of 1 minus cosine of u over 2. If you're working with an equation where you don't know what the value of u is, you would go ahead and substitute in plus or minus the square root. And sometimes things will end up canceling out and you won't have to worry about the plus or the minus. So a couple of notes. For double angle formulas, make sure that you know that these two are different. So sine of 2 times u is not the same as 2 times sine of u, right? One is doubling the angle, the other is doubling the sine ratio of that angle. And then the second note was what I just talked about in terms of the half angle formulas with the plus or minus the square root. The sign is going to depend on the quadrant where u over 2 is in. Let's take a look at some examples. Find all solutions for this. 2 cosine of x plus sine of 2x is equal to 0. Okay, so we see sine of 2x in there. We know we won't be able to solve this unless we are able to factor it somehow, or if we can get everything down to just one function. So since we can't really do anything with the cosine of x there, we'll go ahead and use the double angle formula for sine of 2x. So using the double angle formula, this gives us 2 cosine of x plus 2 sine of x cosine of x equals 0. Now we still have both sine and cosine in there, but we are able to factor out a cosine of x from both of those terms. So let's do that. So in fact, not just the cosine of x, but we also have a 2 that we can factor out as well. So 2 cosine of x, parentheses 1 plus sine of x. And now we can take each of those factors, set each equal to 0. So 2 cosine of x equals 0, 1 plus sine of x equals 0. And then we can solve each of those. So we have cosine of x equals 0 here. Think about where that is. We're talking about on the unit circle, where the x-coordinate is equal to 0. The x-coordinate is equal to 0 at pi over 2. Now, because this was all solutions, find all solutions, this is plus or minus 2k pi. And also at 3 pi over 2, and then tack on the plus or minus 2k pi. All right, let's move on to 1 plus sine of x equals 0. So sine of x is equal to -1. And now thinking of the unit circle, where on the unit circle is the y-coordinate equal to -1? That would be at 3 pi over 2 plus or minus 2k pi. And that's already covered from the other equation. So that would be your answer for example 1. Okay, example 2. Find solutions of 2 minus sine squared of x equals 2 cosine squared of x over 2 on 0 to 2 pi. So not all solutions, just the ones between 0 and 2 pi. Let's start with what we have. We have a sine squared in there, we have a cosine squared in there. Remember that we do want to be able to get everything in terms of just one function, or try to get everything so that we can at least factor something out and solve it that way. Now, since we have the half angle in there, we can go ahead and apply the half angle formula. So note that this cosine squared of x over 2, remember the squared really means cosine of x over 2, the entire thing inside the function squared. So we're going to deal with that first. So cosine of x over 2, we can replace that with the plus or minus the square root of 1 plus cosine of x over 2, and that entire thing is squared before you multiply it by 2. And now once you square this, here this is where the plus or minus actually doesn't matter, because once you square it, it's going to be positive either way. The square root and the squared cancel each other out, and you're left with 1 plus cosine of x all over 2. The 2's cancel here. That leaves us with 1 plus cosine of x on the right. Now that definitely simplifies from what we originally had, but it's still not enough to get us to be able to solve this. Now one thing you can do is you can use the Pythagorean identity to get everything in terms of cosine. So if we replace that sine squared with 1 minus cosine squared, that's going to be able to get the equation down to just cosine. So let's go ahead and simplify this. So we have 1 plus cosine squared equals 1 plus cosine of x. Subtract 1 from both sides, we're left with cosine squared equals cosine of x. Now remember here, you never, ever divide both sides by a function, right? Otherwise, we sometimes may lose solutions. So what we can do, though, is we can move everything over to one side and then try to factor. So in this case, we can factor out a cosine of x, so that's cosine x, parentheses cosine of x minus 1 equals 0. And now we can set each of those factors equal to 0 and solve. So we have cosine of x equals 0 and cosine of x minus 1 equals 0. And again, think back to your unit circle and think about where is the x-coordinate equal to 0. That's going to be at pi over 2 and at 3 pi over 2. And then the cosine of x minus 1 equals 0. That means that the x-coordinate is equal to 1. Think about where that is on the unit circle, and that would be at 0. And those are all three answers that are solutions between 0 and 2 pi.